2010B AP Chemistry Free Response question. Now our question deals with two isomers, N-butane and isobutane. Now the first question is, or the first part is, draw the structural formula of each of the isomers. Include all atoms and clearly label each structure. So the backbone for N-butane is C. And since it has N, it's going to be a straight chain. Then we have the hydrogen. Each piece of backbone. Now with isobutane, we have this short chain and then a piece coming off of the chain, which it branches off because of its isobutane. And then we have hydrogen coming off this guy here. Alright, so the second part B, says, on the basis of molecular structure, identify the isomer that has the higher boiling point. Justify your answer. Well, with N-butane, the structure creates dipoles, which keeps the molecules closer together. So the bonds are stronger. But with this, the structure kind of keeps the molecules apart, which gives it a not as strong structure, not as strong bonds. Concentration equilibrium is 2.5 at 25 degrees Celsius. Now for part C, it says write the expression for the equilibrium constant, Kc, for the reaction. So Kc equals which is isobutane over N-butane. Now it says, suppose that a 0.010 mole sample of pure N-butane is placed in an evacuated 1 liter rigid container at 25 degrees Celsius. So part B, calculate the initial pressure in the container when the N-butane is first introduced, before the reaction starts. So the equation would be N, initial concentration, times R, gas constant, and T, temperature, over V, volume. So our initial concentration is 0.10. Our gas constant is 0.0 821, and our temperature is 25 degrees Celsius, but we have to convert that to Kelvin. So add 273 to that, and we get 298. And divide it by the volume, which it says the volume is 1 liter. So over 1, and we get 0.24. And that is ATMs because it's pressure. Now, part E, the N-butane reacts until equilibrium has been established at 25 degrees Celsius. Now, it says calculate the total pressure in the container at equilibrium, justify your answer.
The pressure, let's see, the total pressure in the container at equilibrium will be the same because the reaction happens in a 1-to-1 ratio. For every 1 mole of N-butane that reacts, 1 mole of isobutane is produced. So it will remain in a 1-to-1 ratio and the pressure will not change.
So it will still be 0.24 ATM.
Alright, so part E2 says calculate the molar concentration of each species at equilibrium. So you're going to have to set up an ice equation, which to guide us we will write out So you have initial, change, and then equilibrium. So the initial concentration of N-butane, which is given, is
0.010
0.01
moles.
Which to convert that to liters, which it gives you, actually to convert that to
Molarity.
molarity, you divide by the liters, which will give you the same number. 6.010 concentration. So then the change is how much of this is at the end. So how much of this is taken away to produce that. So you subtract an x because we don't know the concentration. And then for this one, the initial concentration is 0. So you're adding an x. So then the equilibrium concentration would just be the initial concentration minus x. And then the final concentration for this one is x. So then plugging that back into the Kc equation, you get concentration of products over reactants. So you get Kc equals the concentration of isobutane over the concentration of N-butane. And then solving for x, Kc is equal to 2.5. So solve for x, you multiply both sides, so you get, non-math was here, 2.5 x. And then you would get 1.25. So then you add it and you get 3.5x equals 1.025. Divide both sides, and you end up getting x equals 0.0071 ATM. And then to get the equilibrium concentration, this is the concentration of isobutane. To get the equilibrium concentration of N-butane, you just plug this number back in, and you get 0.010 minus 0.0071. And you end up getting 0.0029 for concentration.
So for part 3 of E, it says if the volume of the system is reduced to half of its original volume, what will the new concentration of N-butane be after equilibrium has been reestablished at 25 degrees Celsius? So the equilibrium doesn't change because it's a 1-to-1 ratio between N-butane and isobutane. But since the volume is being halved, the equilibrium concentration is being doubled. So our equilibrium concentration is 0.0029, or rounded 0.003. so that's doubled.